Good afternoon, ladies and gentlemen. Welcome back to the technical forum at the group exhibit Hydrogen Fuel Cells and Batteries. I'd like to invite you to come and have a seat, have a coffee. The drinks are all on the house, and there's a lovely lady walking around serving you drinks. At this moment, I would also like to say hello and welcome to all our online guests. We are live streaming from the fair, and I will continue with our next speaker. I would like to introduce to you the Head of Customer Service of SFC Energy, and he will talk about the off-grid energy solutions based on direct methanol fuel cells. And over 34,000 SFC fuel cells are in the market, so please welcome with me on stage. Here he is, Mr. Kai Steckmann. Big hands, please.
Thank you very much for the introduction. Yes, my name is Kai Steckmann. I'm working for SFC Energy Group since 8 years now. And I'm here to share some pictures and application experiences from our customers using fuel cells, especially in off-grid installations. I will introduce our product features and go on the topic of methanol we use as energy source, and what makes it possible for us to sell 35,000 fuel cells in the market within the last roughly 10 years. So coming back to our products, this is a product range we are offering to our customers. We have spread the market in 3 major markets, and name it industry, consumer, and defense and security markets. In the consumer business, we address private end users directly. We go through wholesalers and shops which sell equipment for camping and outdoor. The fuel cells in this consumer markets have the brand name EFOY Comfort. They are used to power electricity in recreational vehicles, on sailing boats, or in off-grid houses, small houses for the holiday. The second market is industry. In the industry market, we offer a product named EFOY Pro series. This is usually used in off-grid installations for monitoring, sensing, controlling different kind of applications and tools. And the third market segment is named defense and security. The same core product in a more robust and ruggedized environment is Emily fuel cell. This is used for electric power supply in vehicles or in the locations where the soldiers are working. All 3 products are based on the same core technology. So we have DMFC fuel cells, which means we use methanol, liquid industrial alcohol, as energy source to power our fuel cells directly. To our company is SFC Energy Group. The headquarters is in Brunnthal, close to Munich, called SFC Energy Company. Meanwhile, we have 4 locations worldwide, one in Canada, in the Netherlands, and Romania, and the headquarters in Munich, Germany. In total, we have 250 employees, roughly. We are looking back on 14 years of fuel cell experience. And meanwhile, we have sold 35,000 fuel cell systems in the markets I've shown in the slide before. What is also new and happened within the last 5-6 years to our company is that we developed from a component supplier to a solution and service provider. So we started with developing and selling fuel cell products, and we added batteries and solar chargers to our systems. Meanwhile, we are capable to offer power conversion equipment like DC-DC, DC-AC converters. We offer the whole systems portable in boxes, in isolated boxes, for example, down to minus 40 degrees environmental temperatures. In this box, for example, you find the whole energy supply solution, including fuel cell, battery, solar charger, electronics, everything in one plug-and-play box. And the long-term view is that we also offer services. So we meanwhile are capable to remote monitor our solutions and to plan services for our customers. Coming back to the technology itself, as mentioned, we have fuel cell technology called DMFC, direct methanol fuel cell. So we are using methanol, the liquid alcohol, as energy source. This is connected, or it's filled in a cartridge from 5 to 28 liters. This is the energy source for the direct methanol fuel cell. Like all fuel cells, we also need oxygen for the reaction, so we get it out from the environmental air. So air and methanol is getting inside the fuel cell, and what we for sure would like to produce is electricity. In all of our applications, we are operating the fuel cell as a battery charger. So in all of these 35,000 installations, we have a battery combined with a fuel cell. The fuel cell is responsible for the long-term autonomy and for the power production. The battery is good for covering the power peaks and load changes. And we also have some heat and other products which are created. One is heat from the reaction, and the other one is more or less the same like a human being is breathing. So it is warm, humid air and a little bit of carbon dioxide, which is getting as off product out of the fuel cell. The advantages of the product of the fuel cells itself is that, especially in off-grid applications, we are 100% reliable. So many off-grid sites are powered from solar or wind generators. If you add the fuel cell to the existing power supply solution, you are 100% reliable and independent from any weather impact. So a combination of solar and fuel cell, for example, or of a wind turbine with a fuel cell is 100% reliable even in off-grid applications. Since we are using methanol as energy source with a very high energy density, we have no problem covering long periods of autonomy. This can last up to half a year or 1 year of autonomy that the installation can work without any service or user interaction. In industry applications, all of our fuel cells have the capability that they can be remote monitored, so we can have a look in the system, what is going on, what is the situation on site, the temperatures, is the fuel still there, what is the behavior of the battery, so we can remotely access the power supply in these off-grid sites. The system itself and the fuel is very lightweight and compact. This makes it possible for us to install it and box it and make it portable or mobile so that 1 or 2 people can carry the whole power supply solution. And like fuel cells are, they are quiet and emissions free. Coming to the fuel we are using with our fuel cells, this is more or less the core advantage, that we have very high energy density in our cartridges. So on the left you can see a child carrying a 10-liter cartridge of methanol. 10 liters contain raw energy of around about 45 kilowatt hours, and we produce up to 11 kilowatt hours out of one of these canisters of these cartridges. So you can easily carry 11 kilowatt hours of energy. If you combine it with standard lead acid batteries, you will have to transport 1 pallet full of batteries if we talk about lead acid batteries with a weight of 270 kilograms. So if we talk about battery and DMFC comparison, we are talking about factor 40 to 50 less weight you need to transport to your off-grid site, having the same amount of energy in the installation. And in between you can see other technologies like hydrogen or lithium-ion batteries. Even with the amount of weight or the energy density, all examples, all 4 pictures show roughly an amount of 10 or 11 kilowatt hours of electrical energy. To get an impression how off-grid installations look like, so most of our applications are really off-grid, so far away from the power grid, maybe far away from the roads, that they can only be accessed with pickup trucks or by foot in worst case, or with a helicopter. So on the left you see an installation, a measurement station in the snow, so you can only go there with a helicopter or by foot. Most applications are combine the fuel cell with solar panels and wind turbines, because for sure over the day you have the solar energy for free. If you have wind, you have the wind energy for free, and to make it possible to have 100% reliability over the year and independent from the weather, there are our fuel cells inside the box working or in standby mode depending on charge level of the battery and power supply from solar and wind. And on the left you can also see the solar panels on this box, and here is a vertical wind turbine, so many users combine the fuel cell with solar and wind. This is an example of a mobile application. Since the fuel cells are very lightweight, you can install them in trailers. This is a very popular application from many of our customers. They are creating mobile security cameras or observation towers. So with these applications, you are possible for example, to observe events like here, or railroad tracks or construction sites. So you can move this trailer. You don't need to connect it to any generator or any cable, because the fuel cell is already inside of the system. So bring the trailer to the site, leave it there, switch it on, and then you have remotely access to the power supply and to the pictures you generate with the observation cameras. An extreme installation I would like to show to you as well. This is a station in the mountains, in the Alps. In wintertime, the whole system is covered by snow. So there's 4 or 5 meters of snow on the box, so it's no chance to access the installation. But it is an avalanche pre-warning system, so it has to operate even in wintertime, and even if it's covered of 5 meters of snow. For sure, in a hard winter, solar doesn't work anymore and the wind turbines does not work, but the fuel cell inside stays in operation. And since we can install enough energy to cover an autonomy of 6 months, it is no problem to access, for example, the station last time in September, and then the power is installed for half a year operation for the whole winter, and next year in March or April you go there for the next service and replace the cartridges, and then you have another half a year of autonomous operation. To show how it works, the interaction with the solar charger and the solar panel, I brought a diagram which shows more or less 1 week of data. So the light blue peaks, this is solar charging the battery. So from here to there is 24 hours. So you can see here 3 days of nice weather, and it is fine. The battery and the solar panels are fine to cover the energy demand of the applications. So fuel cell is in standby mode within these 3 days. But here on the left you see a cloudy day, so solar is charging only some minutes, and the sun is going back again, so the battery is more down. And then at least at the second day where the solar is weak, the fuel cell starts charging and provides the energy. So in this example, there's 1 week of power supply, and you can see fuel cell was operating here roughly 4 hours and here for 8 hours, and the rest of the week the power was provided from solar. But solar only is not strong enough to cover the energy demand, so the fuel cell provides 100% reliability for this station. This is our newest product we are showing here on our booth. We have a booth here in the hydrogen and fuel cell area in booth B70, and we have launched a new product looking like that. This is what we call our high power fuel cell. It means it produces 500 watts, which is much for a methanol fuel cell, but for sure for the hydrogen colleagues it is a tiny output power, but for DMFC off-grid application 500 watt is really a huge amount of energy. If you think about powering computers and sensors, 500 watt is really, really much. And the system we supply looks like that. We have clustered 2 500 watt fuel cells there, so we can provide 1 kilowatt continuous power. We have installed 4 cartridges containing 124 kilowatt hours of energy. So an example, if you drain 500 watts of power, you are 10 days independent with the station. Yes, that's more or less for our products. This is to share where we are, share with you where we are. The green dots are our partners, the black dots are our companies spread around the world, and some customers from us at the bottom. That's it from my side. Thank you very much for your attention, and if there are any questions, you can ask them now or visit us on booth B70. Thank you very much.
Thank you, Mr. Steckmann. Also, thank you from my side. For now, I can open the forum for any questions from the audience. Please raise your hand. Okay, you can take all your questions to the booth of SFC Energy, which is located at B70. Yep. Mr. Steckmann will be welcoming you there to answer all your questions. Once again, big hands, please, for Mr. Kai Steckmann.
Thank you.
We'll continue at 3 o'clock. That is only in 2 minutes' time. You can stay seated and have another drink and another coffee. We'll continue with the head of Department Fuel Cell of the Fraunhofer Institute for Solar Energy Systems, and we'll hear testing of balance of plant components.